So the very last thing I said you guys need to know for photosynthesis was the difference between cyclic and non-cyclic electron flow, both of which happen in the light-dependent reactions, which take place in the thylakoid membrane of the chloroplast. But to understand the difference between the two, we need to jump ahead a step to the Calvin cycle. Now remember that the light-dependent reactions make ATP and NADPH to power the Calvin cycle. But if we look closely at the Calvin cycle, which we don't need to know these steps, but remember there are three: carbon fixation, carbon reduction, which makes G3P, which will go on to get glucose. After we make our product, we regenerate the Calvin cycle to go happen again. But you'll notice we put in 6 ATP right here, 6 NADPH right here, and an additional 3 ATP over here. So our amounts of ATP and NADPH are uneven. So that's the reason why we have this discrepancy between linear and nonlinear electron flow. So remember that. We need 9 ATP for the Calvin cycle and 6 NADPH. So if we flip back to the light-dependent reactions, which is what this is, far more detail than you need to know. But remember, there's photosystem 2, P680, excites electrons. They fall down an electron transport chain and make ATP. Then at P700, they do the same thing, and they reduce NADP plus to NADPH at the end. You'll notice, just like we said, there's 1 ATP and 1 NADPH made in this. So after the light-dependent reactions, we're going to have an equal amount of ATP and NADPH. This is a problem because in the Calvin cycle, we need 9 ATP and 6 NADPH. So we're going to quickly run out of ATP, and that's not very efficient. And everything inside of all these living things that we're talking about is about maximized efficiency. So the way that they fix this is by something called cyclic electron flow. So this is linear electron flow. It's a line. Electrons start down here at P680. They come from water. Remember, water splits, gives up its electrons to P680. They get excited, electron transport chain. They go to P700, get excited again, electron transport chain, and they eventually end up at NADPH. So they started at water, and they end up at NADPH. It's a line. Okay? It's one way. They're not going backwards, they're going straight. This is linear electron flow. But after a while, we're going to encounter this problem that we need more ATP. So then what happens is the cell will switch itself into something, or the chloroplast will switch itself into something called cyclic electron flow. Cyclic electron flow makes only ATP. Okay? So we've turned off the NADPH pathway, turned on just the ATP pathway. We're using the same structures as we were in linear electron flow. Here's photosystem 2, P680. Here's photosystem 1, P700. Nothing changes, but they just redirect the way that it goes. So what happens is the electrons that are in photosystem 1, they get excited from the light. They go up, and instead of going down this electron transport chain to reduce NADP plus to NADPH, they get thrown backwards to the previous electron transport chain to make ATP. Then they end up at photosystem 1 again, and the same thing happens over and over again. So instead of passing the electrons on, they're throwing them backwards to only activate the electron transport chain that makes ATP. So by doing this, we've turned off the NADPH pathway, and only the ATP electron transport chain is doing anything. So in this case, we're making only ATP. We're not making any NADPH because we need to make more ATP to make up for the fact that the Calvin cycle uses 9 ATP for every 6 NADPH. So this is going to happen every once in a while to allow for the Calvin cycle to run efficiently. So that's basically what you need to know. Cyclic electron flow uses just P700, photosystem 1. It throws the electrons back to the first electron transport chain to make ATP over and over again. This is different than linear electron flow, which the electrons start at P680. They come from water. They start there. They go down the electron transport chain to make ATP. They end up at photosystem 1. Then they go down a second electron transport chain to reduce NADP plus to NADPH. So that's linear, different than cyclic, which just uses P600, P700, and the first electron transport chain. And the reason that we need to do this is because the Calvin cycle itself uses 9 ATP and only 6 NADPH. So we need to switch the pathway in order to make more ATP to allow for the Calvin cycle to efficiently make our organic molecules, our G3P, which will eventually become